Hi, good afternoon. I'm Vivi.
I'm Ariana.
I'm Fed.
So today we're gonna lead you guys through the concept of photolithography. And I know a lot of groups has already mentioned it before, but very basically, photolithography or lithography is just the process of patterning something to another thing that you want to have the certain pattern. And photolithography is the patterning process, but with the help with light and all its different wavelengths. So for example, there are visible lights like the white lights that's shining on my face, the red lights, green lights, blue lights, all those kind of stuff. And there are also UV lights that comes from the sun and X-rays and all of that. So why I want you guys to do an exercise, because I know we've been sitting here for like 2 hours. So raise your hand if you do not have a phone. I'm sorry for you. Okay, now second question. Raise your hand if you have a phone right by you right now. Almost everyone. So why do I mention this? It's because in each phone, okay, here's a number. I'm not sure about the number because I Googled it, so don't quote me on the number. But in each phone, there are in average about 4 to 7 billions of transistors on them, which are more or less all made of or all made from the lithography process. So with such a wide usage, and here we're gonna explain the lithography process and specifically the photolithography process by analyzing this beautiful cartoon over here.
Oh, okay. So if you can't really tell from this picture, it's basically a cave right here. And then that's sunlight that's directing inside the cave. And then on the two sides, you can see that there's tunnels where there's miners coming in to mine. And then this is basically a representation of photolithography because if you can tell or not, the bottom right here, the bottom of the cave, it's actually the photoresist, which is a really light-sensitive material that covers a surface. And then one of the key components of photolithography is, I believe, exposure of UV lights. And then there's actually two resulting outcomes that's possible. One of them is called a positive resist, which is when the UV light that's shown on the area that's exposed by the UV light is actually hardened. So basically when it's washed by a solution later, that's the area that's going to remain. So that's called the positive resist. And then the other one is called a negative resist, where when the sunlight exposes on the area, it actually weakens the bonds. So the area around it is actually the ones that's going to remain when the solution washes it. So if you read the dialogue of one of the miners on the bottom, it says that we should only mine in areas with no sunlight. So that means that it's usually easier since the dirt or the ground is a lot softer. So the platform right here where the sunlight is exposed, that's a lot harder. So then this is actually a scenario of a positive resist. And then next are the tunnels on both sides. So the tunnels is actually a representation of the circuit, the wires of that was printed onto the circuit board. So the one on the left is actually the thin wire, because as you can tell, the people or the electrons are trying to get through, but the tunnel is so small that it's kind of hard for them to go past. So it's a thin wire, so it creates more power and more resistance. And then the one on the right, as you can tell, there's only like 3 people standing in front of it, so it's really easy to go in and out because it's the thicker wire. And then, it allows for, it's just less power and then less resistance.
Yeah. So now I believe that this picture has really conveyed the idea of the resistance and the step of exposure very clearly, so I guess that you can all believe it. And so I'll just go through the whole process of the photolithography again so that you guys can have a better idea on this. So now we have a material, and the first step is coating. So what is coating? It's just we coat the photoresist onto the substance we want our pattern to on, and this is just literally the process of coating. And the second step is about masking, and it's literally put a mask on the photoresist with the pattern you want. And then it's the exposure. So you bring the stuff under the sunlight and expose it, and on the surface, some chemical reactions will just appear. And then you put the stuff into a developing solution, and this is called simply called developing. And so according to the type of the photoresist, you can have either a negative photoresist or a positive photoresist. So if it is a positive photoresist, the area exposed to the sunlight will be more soluble in the developer solution. And if it is the negative photoresist, the area that is not exposed to the sunlight will be more soluble in the developer solution. And then the next step is about the etching. So in this progress, you just use a chemical to remove the unprotected areas, and the next step is called striping. So in this progress, you just get rid of the unexposed photoresist so that you can get a product you want. And this process, whole process of photolithography contains 6 steps, and is a little bit complicated. And so in order to meet the need, you can just build some more layers. And normally the product we nowadays use is about 15 layers. Yeah, and yeah, that's how I explain this. Yeah, thank you.
Questions?
So you mentioned that in this scenario here, if we're treating the cave as our resist, that this would be a positive resist. Why did you say that?
We said it because you can see in the dialogue on the bottom, maybe you can read it, but it says like something like if we go to the middle where there's light shining, we're going to get burned. So in the positive, when the chemical is like positive, the area where the light is exposed becomes soluble. So whenever like the particles inside the area where light is exposed, it gets soluble, and so it like washes away, and that's why we think it's positive rather than negative.
Of the 6 steps in lithography you've mentioned, what do the minors represent here?
This represents the process of exposure.
They would be developing the resist, right, after exposure, because the sunlight is your light source here, correct?
Yes.
Yeah.
Yeah, I think, so I think that's not what they would be. So if you had to pick something else, what else could they be?
You mean other than developers, or?
I wouldn't even say they're developers.
You wouldn't say if we treat the cave as a resist?
Oh, well, I guess it depends what you treat the cave as.
Because I would think of this as a negative resist.
So, yes. Okay, so I was hesitant to say anything because I can never keep track of positive or negative. And so I never use those words when I talk about things. I just describe the concepts because then you can never say the wrong word. I definitely recommend this to people when it's something like positive and negative that doesn't really have any deep meaning. I do a lot of electrochemistry. You can be the wrong sign all the time. Okay, so, but I think that this would actually be a negative resist. So can you guys take a crack at explaining this, assuming it was a negative resist? And so you may have to reassign what some things are.
At first, when we saw like there's light coming, we thought it was like an exposure.
Yep, that's good.
But we're just confused on why the person at the bottom would say, like, if we get in the middle, it will get burned.
Okay, but
we assume that it's like saying that if they get there, they become like soluble and they're like disappear. That's why they're positive.
oh, okay, but so don't take it to mean that. I think I see now. So let me give you some ways to think about it. Okay, so what did you say the light does to the ground?
It hardens it.
Hardens it. So what would that be analogous to in a positive or a negative resist?
So if it is harder, then it will be insoluble to the developer solution.
Right. So then the sun-hardened dirt would be the cross-linked photoresist. So now, what are the minors? And they could be two things. What do minors do in general? Just in the most vague sense. You've got a miner. They've got a shovel. What is their general job?
Mining and getting rid of the extra stuff or particles on the floor.
Getting rid of stuff. So, given that they get rid of stuff, what are the two things that they could possibly do in this situation?
The etching solution.
They could be the etchant, or they could be, as we said before, the developer. So the developer gets rid of the extra resist, and the etchant gets rid of the extra stuff. And so they could probably be either, depending on how deep down in the dirt, I guess you'd probably call the top layer of dirt the resist and the lower layer of dirt the stuff. Any parent question? Your last chance. What parent hasn't asked a question? We're keeping track.
So many of them.
Oh, come on. Your moment to shine.
Not a parent, but I'll take it.
All right. Hi. Really good explanation on photolithography. So I guess I just had a question. So you guys mentioned photolithography is often used in integrated circuits to make transistors, as in your phones. So quick question for you guys. Whenever I walk by the clean room, I notice that they use yellow light as opposed to white light like we have here. Why would you think that is?
I'm not 100% sure, but yellow light, it's when you take the particle out of the machines directly, there's still like particles around it that can be really interrupting. So the yellow light is kind of more similar to it, so it doesn't immediately bring it to the white light to distract it as much.
Well, let me add just a leading question, which is, when light looks yellow, what colors is it missing?
Violet.
That's right. Violet is what it's missing. Why would you want to be missing the violet?
I think it's because violet has a relatively small wavelength. Yeah, that's why it has like smaller energy, and it can like less interrupt what is like the product being produced in the clean room. And that's why we use.
It has a small wavelength, but is its energy high?
Oh, sorry.
High or low?
Smaller wavelength, higher energy.
High energy.
Yes.
And so what is it similar to? What's right past violet?
UV.
Ultraviolet. UV. And so why would you want to get rid of the violet? When you have your photoresist that's been partly exposed but not yet developed.
Think about what we talked about in our first talk today.
You want to get rid of the violet. You have this photoresist, you exposed it to UV light, and then you haven't done any of the next steps. So you haven't gotten rid of the unreacted material. To be very careful, everybody looks totally dorky because you have yellow light.
So to help you out, so why, if you still have undeveloped material, would you want to stay away from violet light, which we just said was close to ultraviolet? What might happen?
I guess the exposure process would keep going.
You got it.